Hello guys, let us solve amplitude modulation question from previous year papers in GATE ECE as well as instrumentation. So in this you can refer the theory videos for all the concepts and derivations. So this is the very good question that has been asked in previous year. An amplitude modulation signal is given by 4 cos 3200 pi t plus 10 cos 4000 pi t plus 4 cos 4800 pi t. Okay. The thing that was asked is only the total power in AM signal, okay, but I have just put extra questions like bandwidth, carrier signal of power, total power of the amplitude modulation. So this was the question that was asked, and then power in sideband also we will calculate in this question, as well as power in upper and lower sidebands and the efficiency of AM modulation. Okay, so what we will do is we will try to first understand what is this particular signal. So this particular signal, as I have already told you guys, that amplitude modulated signal is what? AC into 1 plus mu cos 2 pi fmt into cos 2 pi fct, right? So if you expand this all, then you are going to get what? AC cos 2 pi fct plus, see here, AC into mu cos 2 pi fmt cos 2 pi fct. So cos A cos B can be written as cos A plus B plus cos A plus B, something like that. So this is how we are going to get AC into mu by 2 cos 2 pi fc plus fm into t and plus AC into mu by 2 cos 2 pi fc minus fm into t. So this is the very good thing that we have. If you try to compare this particular thing with the given question, so I have just compared it here. So you can see this particular term is going to get compared with this particular AM modulation signal. So you will see fc plus fm will be the maximum frequency and fc minus fm will be the minimum frequency. So maximum is 4800 and minimum is 3200. So minimum will come 4 cos 32, this one, and maximum will come 4 cos 4800, the middle one. Okay, and with signal carrier power is this one. Okay, so that's all. Since you have found out this particular terminology, now you have all the parameters that you can write down. So I have written it for you. You can write down the fc is now 2000. Why? Because this is 4000, so cos 2 pi fct, 2 pi I will remove it, so it will become 2000. Here fc plus fm will become how much? 2400. I will just write it down for you. fc will be 2000, here fc plus fm will be 2400, and here fc minus fm will be 1600. Okay, so this is the very good thing that you have understood here. Now fc is equal to 2000, that is 2 kilohertz, fc plus fm 24, that is 2.4 kilohertz, and fm will be what? So you can write down 2400 minus fc is 2000, so that is going to be 400 hertz or 0.4 kilohertz. Okay, similarly fc minus fm is there 1.6 kilohertz, that is also not needed because you already got fc and fm. Okay, these are the two parameters that we already got. Now what is your carrier amplitude? So carrier amplitude AC was 10. Why? Just remember that this is carrier amplitude, not 4 or not this 4. Why? Because we have already expanded this particular equation and we have identified AC is this, AC into mu by 2 is 4. Okay, so AC is 10 and AC into mu by 2 is 4. So if we equate this, here we can get our modulation index mu, which will be 4 into 2 divided by AC, that is 10. So it is going to be 0.8, that is 80%. So AC we have got, modulation index we have got. What would be the carrier power? So my carrier power is AC square by 2, that is going to be 10 square by 2, that is 50 watt. Similarly I have the formula PT is equal to PC into 1 plus mu square by 2. That is total power in AM signal was carrier power plus sideband power. So sideband power was how much? PC into mu square by 2. So the next question was, what is the sideband power? So the sideband power can be PC into mu square by 2. That is going to be PC. PC is carrier power, that is 50, into mu is 0.8, that is 0.8 ka square, that is 0.64 divided by 2. So this is going to be how much? 0.32. So 5 दूना 10, 5 से 15 1 16, 16 watt, right? So you have carrier power, you have sideband power. Say you want, you can write down directly from this formula what is your total power in AM signal, or otherwise you can write down carrier power plus sideband power, and that will give you 66 watt. Okay, so if you calculate from this formula, what will happen? PC, that is 50 into 1 plus 0.64 divided by 2. Mu square is 0.8 ka square, that is 0.64. So this will be 32. So 1.32 multiplied by 50. Okay. So 1.32 multiplied by 50 is how much? That is 66 watt. Okay. So both the formulas you can utilize. Next was, what was the power in upper sideband as well as lower sideband? So for that we have sideband power divided by 2, that will give you 16 by 2, that is 8 watt. This is 16 power. So 16 by 2, that is 8 watt. What is the efficiency of the AM modulation? So efficiency of AM modulation will be sideband power, that is what is the power available in sidebands, divided by total power. So the total power is 66 and sideband power is 16. So that is going to give you 0.24, that is 24.24%. Okay. Now what is the bandwidth of this? Bandwidth was also asked, right? Bandwidth. So bandwidth, since it is, you can see that since it is having only one message signal, so for AM my bandwidth is how much? 2 FM. So that will be 2 times 400 hertz, that is 800 hertz or 0.8 kilohertz. Okay, that's all. So this is how you have understood how to separate out all the frequency components in the available amplitude modulated signals. So it is very important question. You have to identify which one is FC, and which one is FC plus FM, and which one is FC minus FM. In addition to that, what is the amplitude term? Okay, so the amplitude term was derived from this particular derivation. If you want, you can separate out ones, like AC cos 2 pi FCT plus AC into mu cos 2 pi FMT into cos 2 pi FCT. So these two terminology, cos A cos B is cos A plus B plus cos A minus B by 2. So by 2 is coming. So AC into mu by 2 is the amplitude. That's why you can see both of them are 4 and 4. Okay. Thank you guys.